Hi everyone. So I'm going to be doing problem 28 from homework 5, and we're given this lovely block diagram, and we have to find its transfer function. Whoopee. So except for just reducing it to a simple block diagram and then doing a bunch of messy math, we're going to be using Mason's rule, where we change this block diagram into a signal flow diagram, and this is how it will look like. So each node is going to be the resulting signal after it passes through these blocks. So this is our R of S, this is our C of S, and we're going to call these V1 of S and V2 of S. So we know that from in this signal, and then according to our block diagram, this will be our V1 of S, and here this will be our V2 of S. So for the most part, wherever the summers are going to be the nodes in the signal flow diagram. So we know that for V1 of S we have, I forgot to add, so we have plus here, minus and minus, we have plus here, and we have a plus here. So we know that from V1 we have R of S coming in, and we have from V2 we have it coming back, and that's a minus because it's minus up here, so it's a minus. This is a plus 1, we need to clarify. And we know all the way from C of S we have, too far, we have minus 1 coming back. But we know from and then from the block diagram, we know from V1 to V2 we have a gain of, from one pathway we have a gain of S squared, and from another pathway from here we have a gain of 1 over S. Therefore, I scratch that, not therefore. And then from V2 we have a gain of 1 over S to C of S. So that is our signal flow diagram. And based on Mason's rule has a couple steps. For the first step, we have to determine the amount of forward gains we have. So based on our signal flow diagram. So we have 2 forward gain paths, and I'll label them here. So in purple, I have 1. Not too different. 1. How do I do this with highlighting? So, okay. So our first path will be 1, 2, 3. So that's our first path, simple. Our second path will be 1, 2, 3. So that's our second path, because there's another forward, there's another loop here that goes forward. So we have to write down number 1. Our forward paths are T1 equals 1 times S squared times 1 over S, giving us S. And our second one, and T2 is 1 times 1 over S times 1 over S, which means 1 over S squared. So the second step is to find our loop gains, and we have 2 loop gains, which are this backward loop here and this one large backward loop here as well. So our loop gains are negative S squared and calculating this large loop here is 1 over s times 1 over, oh just kidding, times s squared times -1. So, okay. Therefore we get -1, oh just negative s. Third step, we have to find the non-touch loop gains. So these are, non-touch loop gains are any loop gains from number 2 that don't touch any of the forward path gains we found in number 1. And since all the loop gains touch T1 and T2, we have 0 non-touch gains. So now we have to find our delta, which is going to be the denominator of our transfer function. I'm not sure if I said this from the beginning, but we have to find the transfer function of the block diagram. So our denominator of our block diagram of our transfer function is equivalent to 1 minus the sum of our loop gains, which therefore is equal to 1 minus 1 plus s squared plus s. Next, we have to find delta 1 and delta 2 because we have 2 forward path gains. And delta 1 and delta 2 are equivalent to delta subtracting the sum of our loop gains. And since all the loop gains touch T1, therefore delta 1 equals to 1, and again, since all of the loop gains touch T2, delta 2 equals to 1 as well. Technically, the sum of the loop gains, it's the sum of the loop gains taken 2 at a time, therefore it's any loop gains that don't touch each other, like a pair of loop gains that don't touch each other. And then if all is like plus the sum of the loop gains taken 3 at a time, so it's any triplets of loop gains that don't touch each other, and so on and so forth. But since there's only 2 loop gains and none of them touch, therefore it's, and since they all touch the forward path gains, therefore it's that's why we left with 1, because all of them are subtracted, but the coefficient 1. If I had a harder question and I had more time, I would explain it better and show you what I mean by taking 2 at a time, 3 at a time, but this problem doesn't have that, and I don't have the time to do that because of the program I'm using. So now we have all the parts that we need to make find our transfer function. So our transfer function g of s is t1 times delta 1 over delta plus t2 delta 2 over delta. And plugging in the values that we found, g of s ends up being s over 1 plus s squared plus 1 over s squared, 1 over 1 over 1 plus s squared. And cleaning that up, g of s is equal to s cubed plus 1 over s4 plus s cubed plus s squared. And therefore, finally, we have our transfer function. So, yay! We did it! We did it. So, yes, we were able to find the transfer function of this block diagram using Mason's rule, and I hope you found this video helpful. Thanks for watching. Bye!